Good morning friends. Now we are discussing magnetic crack detection test experiment in the material testing lab. Aim of the experiment is to find out the cracks developed on the surface or the subsurface of the given ferromagnetic material. The apparatus used are magnetic field generator and a ferromagnetic powder. So this inspection method will be applied on magnetic ferrous casting so that the invisible defects in slightly subsurface of the given ferromagnetic material can be traced out. So this method is not capable of finding the defects in the deeper subsurface because the influence of the distorted lines. So here the magnetic flux will getting distorted on the magnetic particle. So as you go deeper, so on the subsurface, so the distorted lines of magnetic flux can be easily traced, but as you go deeper inside the given material, so these distorted lines becomes weaker as you as the distance increases from the free surface. This principle here is when the piece of metal given is placed in the magnetic field, so we will find the lines of the magnetic flux, so they get intersected by discontinuity because of the cracks present in the given material. So when the given metal is placed in the magnetic field, so the lines of magnetic flux are getting intersected by the discontinuity. So here magnetic poles are induced on either side of the discontinuity so that an abrupt change we can observe in the path of the magnetic flux flowing through the casting. So this local flux disturbance will be detected by its effects on the magnetic particles, so which collect on the region of discontinuity. Where there is a discontinuity of this magnetic flux, so the magnetic particles will get accumulated and pile up and bridge over the discontinuity. Procedure followed. So clean the surface of the given test specimen to remove any dirt, scales, oil and grease. So demagnetize the component to remove any residual magnetic field present in it. So we have to find out that no magnetic field exists before we conduct the experiment. Apply a thin layer of ferromagnetic particles over the surface to be tested here. Then magnetize the test piece and observe the shape and size how the magnetic particles will be collected where the defect is present. Advantages of this method. So magnetic particle inspection is a very simple and easy technique. So it is free from restrictions with respect to the size, shape, composition and heat treatment process. So limitations of this method is it is to apply this method only for testing magnetic materials. And here finding the defects in the deeper subsurface is not satisfactory. Result of the experiment at the final stage is report what type and size of the defect is found in the given component.
Non-destructive. Non-destructive testing. Magnetic particle inspection. The magnetic particle examination is an excellent method to investigate near-surface defects in ferromagnetic materials. This video shows the basic principle and the practical procedure. The material tester gets the machine ready for use and inserts the test piece between the two poles of an electromagnet. Then she takes a bottle with a suspension of magnetic particles, turns on the electromagnet with a foot switch, and applies the suspension of magnetic particles onto the test piece. Already in daylight, dark lines are visible on the surface. The lines can be seen much better under ultraviolet light, and particularly well at darkening the daylight. The suspension contains pigments that cover the magnetic particles and fluoresce under ultraviolet light. The particles run off in areas free from defects, and they are attracted and clustered near defects. This workpiece shows a whole array of cracks. The basic principle is to magnetize a ferromagnetic workpiece parallel to its surface, as shown in the sectional view. If the workpiece is free from defects, the magnetic field lines run within the workpiece and parallel to its surface. In places of magnetic inhomogeneity, for instance near cracks, the magnetic field lines will locally leave the surface and a leakage field occurs. Now, if a suspension of ferromagnetic particles is applied onto the test piece surface, the magnetic particles will run off at defect-free areas. In places of leakage fields, the magnetic particles are attracted and clustered together, thus indicating the place of the defect. The method works best using a pigment which covers the magnetic particles and shows fluorescence under ultraviolet light. Even cracks can be detected that are not open to the surface but just below it, as long as they are not too far below the surface. But one precondition must always be fulfilled. The magnetic field lines must be perpendicular, or at least at a certain angle to the defect. Otherwise there will be no leakage field and the defects remain undetected. Our test sample has been magnetized in horizontal direction. The magnetic field lines run horizontally. This is the reason why cracks in vertical direction are visible particularly well. To make sure to detect all near-surface cracks, one has to magnetize the sample once more and best perpendicularly to the first time. To do this, the material tester switches the machine over to the current flow method. A high electric current flows through the sample, generating a circular magnetic field. Now the cracks in horizontal direction can be seen very well. The tested sample is a hardened sliding guide. The cracks have been formed during the hardening process and the subsequent grinding operation. Still another test piece has to face the magnetic particle inspection, a section of a large gear wheel. The same procedure again. Placing the gear wheel between the magnetic pole pieces, magnetizing and applying magnetic particle suspension. Already in daylight, there are indications of cracks, and again, they are best visible under ultraviolet light while darkening the daylight. The visible cracks are so-called fatigue cracks. They have been generated during the operation of...
Thank you, friends.